Good afternoon, class. Here's final exam review, part 2. And here's the pledge. Before starting the exam, we pledge not to receive or give any assistance as far as the exam is concerned. That's pretty straightforward. So having said that, we're going to start with the questions that basically we've seen. So let's go start with this one. Observations show that the length from nose to tail of a Siberian tiger is given by this formula, where W is the weight in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age. With this formula, how long is a tiger when it's 100 years old? So there are a couple of different ways to do that, and this is elementary algebra. So first and foremost, let's plug in 100 here. So two decimals, two zeros cancel each other. 21 and 3 is 24 kilograms. You plug in here, and you can calculate the length at that point. Now, this is elementary algebra. Now we get to the calculus. At what rate, that means the derivative, is the length increasing when it's 100 days old? So we want the L dt. So we're going to write it in this format. We're going to go with the Leibniz's notation. dy dt is dy du du dt. And so from L to t, the intermediate variable is w. Therefore, dl dw dw dt. So having said that, first we're going to differentiate L with respect to w. So that's 0.25 times 2.6, w to the power of 2.6 minus 1 over 1.6. Then dw dt, this one is just 0.21. And if we multiply the three numbers and put it in front, this is what we get. Now, if we want to make it a function of t, we have to replace the w and then replace the t with 100. However, in the previous part, we know at t equals 100, w is 24. Replace it, and there you have it, 22.0532 millimeters per day. So this is very straightforward. The second method is to find L of t. That means replace the w. This is a composite function. L of t is 0.25. W is replaced with 3 plus 0.21 t, and the rest is history. At this point for part A, if I replace the t with 100, I will get exactly the same thing that I have here, 969.369 millimeters. 1,000 millimeters is 1 meter, remember that. Now, the second one, the L dt or L prime, 0.25 remains times 2.26, the same thing to the power of 1.6, and the derivative of the inside is 0.21. This is by the chain rule. The product of those three numbers, we put them in front, and notice these two would be identical if we replace the W right here. And now if I plug in 100, I get exactly what I had here in the first place. So that's pretty straightforward. I hope everybody is okay with that. We're going to move on. We want to find an equation of a tangent line. And that means we need two things. We need the pair is given, and we need the derivative, and then plug in. So first and foremost, this is x times e to the power of y. And this is y times e to the power of x. Both of them use the product rule. For this one, again, we're going to go with the product rule, f prime g plus g prime f. So this is 1 times e to the power of y plus e to the power of y is itself times y prime, because y acts like a function g of x, and then by the product rule times x. And now we move on to this one. Y, the derivative is y prime times g, which is e to the power of x, plus g prime is itself, e to the power of x, times f, which is y, and 1 is a number, results in 0. So right here, you can plug in 0, 1, and find y prime, becomes the slope. But let's solve for y prime. So having said that, we notice y prime we have here. So we're going to keep these two. We factor the y prime out. This gives us e to the power of y times x, or x e to the power of y, and this gives us e to the power of x. These two go to the other side, become negative. Divide by the parentheses here. This is y prime. Again, bear in mind, this is not the derivative function. Rather, it's not the slope. It's the derivative. It's the function. It becomes a slope if we plug in 0 instead of x, 1 instead of y. And as you know, this is obviously 1. This, because of 0, is 0. This is also 1. And we have minus e plus 1 over 1, or simply minus e minus 1. So y equals mx plus b, because this is a y-intercept. This means b is given as 1, and y is parentheses minus e minus 1 times x plus 1, and that's an exact way of writing it, and we are done. What about this one? Again, it's a product of two things. We're going to call it fg, although this is f of x. You can think of it as h of x. And so we are going to go with the product rule, which means the derivative of the first piece, exponential is always itself, times 2 by the chain rule, times ln x by the product rule, ln x plus ln x, the derivative is 1 over x times f by the product rule, and we're done. We just factor the e to the power of 2x out, and it becomes e to the power of 2x times parentheses 2 ln x plus 1 over x. The first step is whenever we deal with logs, can we decompose them? The answer is in this case no, so flip this over. Then by the chain rule, the derivative of the inside times 2x, so we are here. And finally, you look at the base. The base is e, we would be done. It's not. Therefore, times 1 over ln b times 1 over ln 5, and you rewrite it. What about this one? The best course of action would be to decompose. And it's ln of the top minus ln of the bottom. Ln of the top is ln2 plus ln x. It itself is a product. So this just uses the product rule, and this uses the quotient rule. So ln2 is the number 0, ln x is 1 over x minus 1 over 2x minus plus 1 times 2. As you can see, we are done with calculus. We are going to take a common denominator, and it's x times 2x plus 1. So 1 times 2x plus 1 minus 2 times x. And this is the final answer, everybody. Logarithmic differentiation is used in many situations. One of them is when the base and the exponent are both functions, or when the function given is very complicated. So having said that, what are the steps? Number one, take a natural log of both sides. So when I take the natural log of this one, becomes ln y, and when I take the natural log of this one, the power rule puts the sign x in front. So we're going to differentiate implicitly both sides. So this would be 1 over y times y prime, and this would use the product rule. Sine gives you cosine times ln x. ln gives you 1 over x times sine x. And as you can see, I can take this one to the other side. In other words, multiply both sides by y. This goes away. So we're going to solve for dy dx or y prime. And so y prime is y times whatever is here, and replace the y, and you're done. So that's one way to do that. And it's fine. The second method is to know e to the power of ln x is x. Therefore, we can say y is x to the power of sine x, and we change it to e to the power of ln x sine x, which is e to the power of ln x times sine x, and we work on this to differentiate. This becomes very simple, ultimately very similar to what we have here. So I hope everybody is okay with that. Y equals x sine inverse of 3x. Again, we are looking at the product of x and sine inverse. That means we are going to go with f times g. So obviously, the derivative of x is simply 1 times g sine inverse of 3x. But what about this one? I'm going to remind you the derivative of sine inverse is 1 over the square root of 1 minus x squared. And so what about sine inverse of a function? You put g prime. If it's g of x, you put g prime here, and you raise the g of x to the second power. In other words, let's write it in this fashion. Okay. Over here, remember the function is 3x. So you put the 3 here and the function. So g of x goes in here, 3 goes in here. And by the product rule times f, which is x. And you just rewrite it. The final answer is sine inverse of 3x plus 3x over square root of 1 minus 9x squared. All right. Now, what about this one? Well, let's put a raised dot in between. That's a product rule. And we're going to call it FG. Okay. And we're going to work on that. And of course, this is 1 minus x squared to the power of 1/2. All right, so let's see how that works. FG 1 times cosine inverse. And cosine inverse minus 1 over square root of 1 minus square root of 1 minus x squared times f, which is x. So that one is done. Now this one, we put it in a format that the power rule, extended power, can be used minus 1/2, 1 minus x squared to the power of negative 1/2. The derivative of the inside is negative 2x. We're done with calculus. We're going to rewrite this. So this is just cosine inverse. This is plus minus x over square root of 1 minus x squared. What about this one? Please understand that we have a fraction bar. At top, we have 1 and negative 2x, so it's minus 2x. At the bottom, we have 2, and this one goes down, becomes 1/2. Now, this one cancels out. This one gives us minus x. Negative in front makes it positive, and this means the square root. These two cancel each other. This is the final answer. The distance in meters of an object from a starting point is given by this function. What is the velocity from 2 to 4? It's the average velocity total distance over total time. So S over 4 minus S of 2 over 4 minus 2. Meaning plug in 4, plug in 2, and evaluate. And that's elementary algebra, becomes 52 minus 38 over 2, which is 7 meters per second. What is the instantaneous velocity and acceleration? Now we are going to go with the derivative. V is S prime, 4t minus 5, 6 seconds. 4 times 6 minus 5 is 19 meters per second. Acceleration is the second derivative of the position function. So A is V prime or S double prime. And if you differentiate, you get 4 meters per square second, just because A is dV. A of t is that's why it's meter per second per second. When does the object reach 31 millimeters per second? That's the speed. Set it equal to 31. Move Negative 5 becomes positive 5. 36 divided by 4 is 9 seconds. A 180 degree, let me erase my. A 180 degree turkey is removed from the oven and placed in a 74 degree Fahrenheit room. After 15 minutes, it has cooled down to 136 degrees Fahrenheit. Find the general solution for it. Even if they don't ask you for the general solution, it's really a good practice to find that and then move on with different parts. So this is the methodology, the Newton's cooling theorem. T of t is y sub 0 e to the power of kt plus t sub s. Y sub 0 is T sub 0 minus T sub s. T sub s is the surrounding temperature and so forth. Starting with T sub 0, the initial temperature is 180 degrees. We bring it to the room temperature. That is the surrounding T sub s, 74 degrees Fahrenheit. And after 15 minutes, T of 15 becomes 136 degrees Fahrenheit. So that's the given, first and foremost. So what do? We start writing y sub 0 is T sub 0 minus T sub s. Therefore, y sub 0 is 180 minus 74, and y sub 0 is 106. So we are going to rewrite this as T of t equals 106 e to the power of kt plus T sub s, which is 74. Now, as you can see, everything is there. What's missing is k, and therefore, this piece of information will help us find the missing k. So I'm going to replace the lowercase t with 15 minutes, uppercase t with 136 degrees Fahrenheit. We are going to subtract 74. So we get 106 e to the power of k times 15, or 15k equals 62. We're going to divide by 106. And I'm going to keep it as that. Of course, this can be simplified, as you know, and we're going to take a natural log of both sides. The left side becomes 15k. And k is the right side divided by 15. And if you put it into a calculator with a bunch of decimals, and when I say bunch, 1 or 2 is not good enough, this is what you get. T of t equals 106. E to the power of negative 0.03575 t plus 74. Notice the number of decimals. You have to use a lot of decimals. Now, you can actually use an exact answer in the following manner. So over here, e to the power of 15k is 62 over 106, or 31 over 53. So if I raise both of them, to the power of 1 over 15. Why 1 over 15? Because I want to get rid of the 15. I get e to the power of k. So if e to the power of k is that, e to the power of kt is the same thing times t, this one. And so now, I hope you see, take a look at what we had here. This is a little bit more precise. T of t is 106, parentheses 31 over 53, to the power of t over 15 plus 74. So we're going to rewrite what we found in the previous page. What is the Turkish temperature after 60 minutes? Notice T is 60. So if I replace it here, 60 is divisible by 15. It's better to go with that one, which is 4. So 31 over 53 to the power of 4 times 106 and plus 74. It gives you the answer. As far as the number of decimals, you always go with many, many decimals, although unless they ask for a specific number. So how long does it take for it to cool to 110 degrees? You can use any of it and set equal to 110. So the first thing is subtract 74, divide by 106, take a natural log of both sides, the left side becomes the exponent, and t is the right side divided by the coefficient of t. If you put that into a calculator, 30.2, roughly about 30 minutes. So that's pretty straightforward. A related with problem, a small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at the rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. So we are looking at a circle. That means this shape. That means from the center to the circle is the radius, both sides is the diameter, d is 2r, c is 2 pi r, a equals pi r squared, and we need the a. In other words, every piece of information from circle we should have. So a equals pi r squared, and what is given? The r dt is 3/2 feet per second, and we want the a dt when r is 4 feet. So this is the translation of the question. So a is pi r squared. We want to find the a dt, or take a derivative with respect to t. That means pi remains, and r squared becomes 2r dr dt, or 2 pi r dr dt. Replace the r with 4, dr dt with 3/2. 2 cancels out the 2, we get 12 pi and square feet per second, or this number roughly, which means the area of the balloon is increasing at a rate of 12 pi square feet per second. Why is it increasing? Because this is positive. If it happened to be negative, we write decreasing. Find dy dt for this equation where dx dt is 3, so on and so forth. First and foremost, the moment you see dy dt, that means t is the independent variable. So that means the derivative of x is no longer 1. So 4 times same thing cubed by the chain rule, the derivative of the inside is 5 dx dt plus dy dt minus dx dt equals 0 because 6 is a number. And normally I like to solve for dy dt. In this case, you can just plug in. So we're going to plug in all the values we have. Obviously, this is 10 minus 9 is 1. So 1 cubed remains as 1. 5 times 3 is 15. You distribute the 4. 60 and negative 3, they add up to 57. They move to the other side, negative, and divided by 4. dy dt is minus 57 over 4. Okay, that's pretty straightforward, everybody. We are going to move on. A 20-foot ladder leans against the building. The base of a ladder slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. I can't emphasize the importance of drawing and defining our variables. So here's the building, here's the ladder, and it's moving this way, okay? And we have to define our variables. Now, this one is whatever you want it, x, this one is y, that's how you define it. And the ladder is fixed at 20 feet. As it moves this way, slips away, it creates a speed dx dt is 2 feet per minute. Why dx dt? Because we call this x. As it comes down, it creates the speed dy dt. Why dy dt? Because we call this one y. That's what we want. So dx dt is 2 feet per minute. Dy dt is missing at the moment that the base x is 12 feet. And because this is a 90-degree angle, we can use Pythagorean theorem, a squared plus b squared equals y squared. So x squared plus y squared is 20 squared, and we are going to work on that. So that's the information, piece of information from geometry. Differentiation 2x dx dt plus 2y dy dt equals 0. 20 squared is the number 400. And we got everything, and we notice y is missing when x is 12. So we are going to use this formula and find the missing y, which becomes 16, plug in, move the 48, and divide by 32. Again, -3/2 feet per minute. Bear in mind, x is increasing, dx dt is positive, y is x is increasing, dx dt is positive, y is decreasing, it's negative. Therefore, the height of the ladder is decreasing at the rate of 3/2 feet per minute. When we mention decreasing, we don't have to include a negative sign. That's important to understand. Falling sand is forming a cone-shaped pile. The volume is given as such. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches. Again, it can't be done without the drawings. Here's the cone shape, and we should know the volume is 1/3 pi r squared h. Volume is 1/3 pi r squared h. dV dt, because this is the rate of the volume, dV dt is 54 pi cubic inches per minute. Height h is 2r. H is 2r, as you can see. And we want to find the r dt when r is 6. This explains everything. And so, as you can see, volume is a function of the radius and h, two different variables. And all you have to do, make it into one variable. Because we want the r dt, we're going to make it a function of r, so replace the h with 2r. If we wanted the h dt, we would say r is h over 2 and replace it. And this is 2/3 r cubed. We want to differentiate this dv dt. We start with 2/3 pi, and then r cubed is 3r squared dr dt. 3 and 3 cancel each other, 2 pi r squared dr dt. Replace the r with 6, dr dt can be found, and dv dt is 54 pi. As you know, this is 36 times 2 is 72, so 72 pi. We are going to divide both sides by 54 pi. So dr by 72 pi. We want to get rid of this. So we're going to divide by 72 pi. Pi and pi cancel each other. 54 and 72. They're both divisible by 18. We get 3/4 of an inch per minute. Units of the radius over units of time, which means the radius of the cone-shaped sand forming is increasing at the rate of 3/4 of an inch per minute. Why is it increasing? Because this number is positive, everybody. Use differentials to approximate square root of 27. So first and foremost, we need a function. And all you have to do, read square root of 27, so square root of x. That's your function. Then you need a number. Choose a number x close to 27, for which the square root is easy to compute. Obviously, it's 25, because we should know square root of 25 is 5. That's the closest number. And so, what is delta x or dx? The difference between the two, 27 minus 25 is 2. Please understand, it means we know square root of 25 is 5. We don't know square root of 27 because 2 is positive. Square root of 27 obviously is larger than square root of 25. So that's why it's positive. And on the other hand, if we wanted the square root of 24, again, I just write it. If they were asking for a square root of 24, dx would be -1, because now it's 24 minus 25. So having said that, f of x plus delta x is f of x plus dy. We have f of x, we don't have dy, so we are going to differentiate. To differentiate, we're going to rewrite it as x to the power of 1/2, and it becomes 1/2 square root of x. Dy is the same thing times dx, and there you have it. We want the square root of 27, or f of 27. That means x is 25, delta x is 2. We are going to replace the x here and here with 25, dx with 2. As you know, square root of this is 5, this is 5, 2 times 5 is 10. 2 and 2 cancel each other, actually. This. So 5 plus 1/5, or 5 and 1/5, or 5.2. Comparing it to the actual number, it's not too bad. It's as good as for the first one, including the second one. So it's pretty good. And of course, 2 is fairly large compared to 25. If you make it smaller, it's a better approximation. So we're done. The second one is linearization. Tangent line will give you the same result, L of x. You don't have to memorize that. Go with the easy point slope. We want a tangent line L of x where the function is square root of x and x is 25. That's what we are looking. So the pair, when we plug in 25, we get 5. So that's the pair 25 comma 5. M, you have to go with this one. Let me erase everything. Here's where you find the slope. If you plug in 25, you get 5 times 2 is 10, 1 over 10. And y minus y1, that means y minus 5 equals m1 over 10, x minus x of 1 over 25. And you do the work, you end up with this. And we want square root of 27 or L of 27. So if I replace the x with 27, I will get exactly what I got here. And I'm going to leave it for you to verify that. The derivative of sinh x. So reminding you by definition, cos x or hyperbolic cosine is e to the power of x plus e to the power of minus x over 2. Sinh x or hyperbolic sine has a negative in between. So if I want to differentiate sinh x, I have to differentiate this piece. And I hope you see that this is 1/2 remains. Just differentiate this one, you get itself. Differentiate this one is itself times -1, so this becomes plus, and that's equal to cos x. So in other words, we prove the derivative of sinh x is cos x. By the way, the derivative of cos x is sinh x and so forth. Now, what is the derivative of 10x squared? Sinh of 10x squared. Again, it's cos of 10x squared, okay? And the reason I put it in 2 steps, because just as I did with the sinusoidal functions or trigonometric functions, the same thing here. Sinh, I pause and I say cos, and then 10x squared, I write it. And then the chain rule says, what is the derivative of 10x squared? 20x. And we have the answer here. In other words, we are looking at this one, right? And we are done. What about this one? Again, the moment you see cos, the answer is sinh. Okay. And of course, sinh is meaningless without the argument. And then square root of x, by now we know it's 1 over 2 square root of x, and you rewrite it. Hyperbolic tangent, as you know, the hyperbolic secant squared. So this is this, okay? So hyperbolic secant squared of what? The same thing. And then the derivative of this argument is e to the power of 2x times 2. Rewrite it, and you're done. Find the absolute max and minimum value for this case. This is what is known as extreme value or closed interval theorem. Okay. So when you have a continuous function in a closed interval, that will work. And so let's discuss continuity before we go over the process. All functions are continuous in their entire domain, meaning if you can come up with a domain, that's where the function, that's the meaning of the domain, the function is continuous there. Polynomial functions, f of x equals a sub n x to the power of n all the way to the end, where a sub n is not 0, n is a whole number, and w is 0, 1, 2 to infinity, domain is all real numbers. If the domain is all real numbers, this is a polynomial of degree 2 times 3 or 6. If the domain is all real numbers, then it's continuous from negative to positive infinity, also continuous in the given interval. Therefore, we can follow this. First and foremost, we want to find CPs. So f prime 3 times x squared minus 1 squared times the derivative of the inside 2x, and we rewrite it. We set this equal to 0. Either x is 0 or x squared minus 1 is 0, and x gives us 0, x squared equals 1 or plus minus 1. So there are 3 answers. Also, f prime doesn't exist. That doesn't produce any solution because f prime is a polynomial of degree 5. Why 5? 2 times 2 is 4, and this is 1, 5. So there are three cases, and all of them are okay because a -1 is one of the endpoints. 1 and 0 are both in between. We're going to evaluate the original function at those four pairs. So if I replace the x with -1, square it becomes 1 minus 1 is 0, so I get 0 here. If I plug in 0, I get -1. Cube it is -1. If I plug in 1, the same thing happens here, becomes 0. And if I plug in 2, 2 squared is 4, -1 is 3, cubed is 27. And that's the absolute max. This is the absolute mean, and we write it in the following manner. Absolute max is 27. At this pair, absolute mean is -1 at this pair. The mean value theorem, given f of x equals 5 minus 4 over x, find also in the interval of 1 to 4 such that the slope of the secant line equals the slope of a tangent line. Here's the mean value theorem. Okay, everybody. F is a continuous function in the closed interval of a to b, differentiable in the open interval of a to b. There is a number c in the open interval of a to b such that f prime is f of b minus f of a over b minus a. The cross product gives you the same thing here. Okay, I hope you see that they are the same in essence. Doesn't matter you write it in this fashion or the other fashion. So having said that, f of x is 5 minus 4 over x, or if it helps, you can even write it as 5x minus 4 over x. So that's a rational function, obviously, and you can easily graph it. It's really not a big deal. And so we have the vertical asymptote x equal to 0 and the horizontal asymptote y equals 5, okay? Just in case. So 1 and 4, we locate 1 and we locate 4. And we connect them. The point is somewhere in between 1 and 4. There is a line parallel to that. That's the meaning of this. And so we want to find this point, which is missing in action. Now, we have to look at each case. We understand this is a rational function. And a rational function is continuous in the domain. The domain x can't be 0. The domain is all real numbers except 0. That's how you write it. And of course, 1 to 4 is a part of that. Therefore, it makes it continuous in 1 to 4 and differentiable in the open interval of 1 to 4. It's a rational function. Please understand this means 0 has been excluded. So that's pretty straightforward. So having said that, f prime of c is f of 4 minus f of 1 over 4 minus 1. So if I plug in 4, it's easier here. I get 1. 5 minus 1 is 4. If I plug in 1, I get 4. 5 minus 4 is 1. And f prime, if I want to differentiate again, it's easier to deal with this. Let me erase this. So if I want to differentiate it, just this is easier. Minus 4x to the power of minus 1. And it derivative is minus 4 times -1, x to the power of -2, or 4 over x squared. And if that's f prime of x, we set it equal to 1, x squared becomes 4, x is plus minus. There are two answers. However, between 1 and 4, only 2. Again, please understand that there are two answers. By the way, -2 is somewhere here, okay? -2. There are 2 points, but remember, between the two, there is 1. There happen to be, and that guarantees only. Reminding you of the Rolle's theorem, by the way, if f is continuous in the closed interval, differentiable in the open interval, and f of a is equal to f of b, then there is a point c such that f prime equal to 0. Okay, that's if f of a equals f of b. So That means in essence, if f of a and f of b is equal to f prime becomes 0. That's the idea. That means the horizontal line. So having said that, let's find the following limit, and there are various methodologies. If you plug in 1, you get ln 1 over 1 minus 1, which is 0 over 0. Because we proved it's 0 over 0, we may use L'Hopital's rule. That means we are going to use the L'Hopital's rule by differentiating the top 1 over x over 1. So this is representing the L'Hopital's rule. Sometimes they write it as such, equality, and they put the h at top, okay? So if I plug in 1, I end up with 1 and I'm done. What about this one? First, I'm going to show you that it's 0 over 0, and then we take it from there. If I put 0, I get e to the power of 0 minus e to the power of minus 0, which is again 0, minus 2 times 0 over 0 minus sine 0. And I hope you see these two cancel each other because 1 minus 1. We get 0 over 0. The idea is that, yes, I can use the L'Hopital's rule. So let me erase my work and use the L'Hopital's rule. So the derivative of this one is itself. This one is minus minus plus e to the power minus x. This is minus 2. This is 1. This is minus cosine x. Now, if I plug in 0, e to the power of 0 and e to the power of 0, this is 2 minus 2, 0. 1 minus cosine of 0 is 1. So 1 minus 1 is 0. Again, I'm going to use L'Hopital's rule. So this is itself, minus e to the power minus x. This goes away, minus cosine becomes positive sign. If I plug in, I get e to the power of 0 minus e to the power of 0. 1 minus 1 is 0, sine of 0 is 0. And again, I'm going to use L'Hopital's rule. This is itself, this is plus e to the power of x, and this is cosine x. Now, if I plug in 0, I get e to the power of 0, which is 1, e to the power of 0, which is 1, cosine of 0. So let's just write that. E to the power of 0 plus e to the power of 0 over cosine of 0. And it's 2 over 1, or simply 2. What about this one? Just plug in. If I plug in, I get 1 minus sine of power 2 over cosecant 1 over sine of power 2. As you know, sine of power 2 is 1, so we get 0 over 1 or 0. So there is not much to it, everybody. There are various indeterminate forms. One of them is infinity minus infinity. For example, the limit of cosecant x minus cotangent x. If you plug in, you get infinity minus infinity. So the technique is to rewrite them as 1 over sine for cosecant, cosine over sine for cotangent. Take a common denominator. And I hope you see, if I plug in 0, this is 1 minus 1. The cosine of 0 is 1. Sine of 0 is 0, so we get 0 over 0. Therefore, I'm going to use the L'Hopital's rule. 1 becomes 0, minus cosine becomes sine x. When I differentiate, sine becomes cosine x. And now if I plug in, sine of 0 is 0, cosine of 0 is 1, 0 over 1 is 0, and I'm done. What about this one? If you plug in, you get minus infinity minus negative infinity, or infinity minus infinity, or indeterminate form. So the technique is to use logging properties, and that would be the quotient rule. If we look at number 6, we can go from left to right or right to left. So we write it in this manner. We can interchange limit and natural log. And if you plug in 1, you get 0 over 0. Therefore, you can use the L'Hopital's rule. So keep the ln and take the limit of now 7x to the power of 6 over 5x to the power of 4. If I plug in 1, this is 7, this is 5. So I get ln of 7 over 5, which is an exact answer, everybody. Use Newton's method to approximate the 8th root of 500 to 8 decimal places. First and foremost, let that be x. Some students got some of the answers that were strange without really showing how they arrived at it. So you let x represent this. If I raise this to the power of 8, this becomes 500. If I bring them to the same side, x to the power of 8 minus 500 is 0, and I'm going to call it f of x. So that's how you find f of x. Differentiation results in x to the power of 7. And according to Newton's method, you have to go with this. X sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n. And where do we begin? 8 root of 256 is 2. 8 root of 6561 is 3. Therefore, you start somewhere. For example, you let x sub 1 be 2. You have to let your reader know where you begin. So now, this is the first one. What is the second one? We go with this formula and we say x sub 2 is x sub 1 minus x sub 1 to the power of 8 minus 500 over 8 x sub 1 to the power of 7. And so we're going to replace wherever we see x sub 1 with 2, do the work, and we show the reader step by step with details how we arrive at it. And that's pretty good. We have x sub 1, we have x sub 2, and now we may use a calculator. For this case, y sub 1 is the function f of x, y sub 2 is f prime of x. 2, the first x sub 1 is stored in x, and then x minus y1 over y2 stored in x. And how far do you go? We want 8 decimals, just for the sake of argument. If you look at this one, 1, 7, 4, and then this is changing. So this is not good enough. You have to continue. You continue more, and you notice 1, 2, 3, 4, 5, 6, 7, 8 are identical. So when you stop here, 7, because the next one is 6, changes to 8, and that's your answer. So you have to show step by step and exactly what you do. Use the left endpoints, right endpoints, and midpoints rule with n equals 5 to approximate the integral of 1 to do 1 over x, 1 to 2, 1 over x dx. Of course, this is an approximation. And if you take a limit, it's an exact. And these are different formulas, the Riemann sum. And I'm going to stick with the general format, and I don't have to memorize any of them because first I want to show you how we deal with that by noticing what is it that we need to do. Number one, the function is y or f of x equals 1 over x. A is 1, b is 2, and they said n equals 5. And here's the graph of y equals 1 over x. Everybody should be familiar. And we want to go from 1 to 2. And that means we want this area. So one way to do that is to blow it up, make it huge. And calculate delta xb minus a over n becomes 1/5 or 0.2. And now this part from 1 to 2, I'm going to cut it into 5 pieces. And I'm going to go with the line segment, starting with a equals 1, b equals 2, and I'm going to add 0.2. So those are the endpoints. So I'm going to start with the left endpoints. That means L sub 5. And the answer is delta x, which we know it to be 0.2 times. Let me erase my work. For the left endpoints, everybody, we are going to use all of the left endpoints except b, which means, pay attention, we need f of 1, we need f of 1.2, f of 1.4, f of 1.6, f of 1.8. We don't need the b, the last one, because those are left endpoints. So what is f of 1? 1 over 1. F of 1.2, 1 over 1.2, and so on. You put it to a calculator, you come up with the answer, you're done. Now we're going to do the same thing with the right endpoints. To do the right endpoints, again, we need delta x, which is the same thing, 1/5. And this time, we're not going to use this one. We're going to use the rest of it because we are using the right endpoints. So that means f of 1.2, f of 1.4, 1.6, 1.8, and the last one 2. We add them up and then times delta x, and you evaluate it. Also notice these two are the same, so it makes it very easy for the calculation, and you have your answer here. Finally, we want the midpoint. So how do we go with the midpoint? Let me erase the work again. So midpoint, the first midpoint is here, which means 1.1. And then all you have to do add 0.2. The next one is 1.3, 1.5, 1.7, 1.9. So do I have to memorize the formula L sub n, R sub n, M sub n? No. Just do that, do the math, and you'll see the answer, and you're done.